There is a heat pump in a laboratory in Cambridge, England right now that heats a 1,500 square foot home using less electricity than a hairdryer. There is no refrigerant inside it, no compressor, no moving liquid of any kind, and it is projected to last 40 years without service. It cannot be legally sold in the United States. Not because it does not work, it works. Independent testing puts its coefficient of performance at 4.2, which means it produces 4.2 units of heat for every unit of electricity it consumes. The best gas-driven residential heat pump on the American market right now sits at about 3.8. The technology is also already in stores. If you fly to Shanghai today, you can walk into a higher showroom and buy a Magnetocaloric wine cooler for $890. The compressor in your refrigerator cost more to manufacture than the entire cooling assembly inside that unit. So why can a Chinese consumer buy this technology at a higher store while an American homeowner cannot legally install one in their basement? The answer is not safety. The answer is not technical readiness. The answer is $42 billion a year, 3 American companies, and a federal test protocol written decades ago that quietly makes the entire technology illegal by definition. Let's get into it. To understand what a magnetocaloric heat pump is, you have to understand a quirk of physics that scientists have known about for almost a century, but only recently figured out how to exploit at useful scale. Certain metals, when placed in a strong magnetic field, get hot. Take them out of the field and they get cold. The most useful of these metals is gadolinium, a rare earth element that responds dramatically to the magnetic effect at temperatures very close to where humans actually live. A gadolinium plate sitting in a strong permanent magnet field warms up by roughly 5 degrees Fahrenheit. Slide it out of the field and it cools back down by the same amount. Slide it back in, it warms again. The energy is real, the heat is real, and nothing inside the system gets consumed in the process. A magnetocaloric heat pump takes this effect and runs it in a continuous cycle. A series of gadolinium alloy plates rotate slowly through a permanent magnetic field. As they enter the field, they release heat into a water loop that circulates through your home. As they exit the field, they absorb heat from the outside air or ground. The whole assembly has one moving part, the rotor, and uses permanent magnets that never wear out and never need to be replaced. The technology was a laboratory curiosity for decades. Gadolinium was too expensive, the magnets too weak, and the physics too finicky to produce useful amounts of heat at residential scale. Both of those problems have now been solved. Camfridge, a British company spun out of Cambridge University, currently has working residential prototypes delivering a coefficient of performance of 4.2 while drawing roughly 380 watts to heat a 1,500 square foot home. The German Fraunhofer Institute for Physical Measurement Techniques has independently confirmed similar numbers in their own test cells. Astronautics Corporation in Wisconsin has been running parallel research for over a decade. None of these are vaporware, the hardware exists. The numbers are reproducible. Independent labs have validated them. The projected manufacturing cost at volume sits between $480 and $620 per residential unit. For comparison, a conventional residential heat pump retails for between $4,000 and $7,000 installed, with the compressor alone accounting for roughly a third of that cost. Now consider what is missing from this technology. There is no refrigerant gas of any kind. The global warming potential of a magnetocaloric heat pump is effectively zero because the working components are solid metal plates and a closed water loop. Nothing inside it can leak into the atmosphere in a form that warms the planet. This matters more than it might sound. Refrigerant leakage from existing American HVAC systems is a meaningful contributor to industrial greenhouse gas emissions. R-410A, the dominant residential refrigerant, has a global warming potential that industry estimates put at roughly 2,000 times that of carbon dioxide. The newer R-32 is better, but still rated at several hundred times. Every leaking compressor in every American home is contributing to atmospheric warming on a scale that dwarfs the heating energy the unit is actually saving. A solid-state magnetocaloric system removes that problem from the equation entirely. There is also no compressor. The compressor is the most failure-prone component in any conventional heat pump. It is the reason your unit dies after 12 to 15 years and needs $5,000 of replacement work. Magnetocaloric systems use a slow rotating assembly with permanent magnets and ceramic bearings, projected to operate for 40 years before any meaningful service is required. There is no fluid under pressure anywhere in the system. The components do not leak, do not corrode, and do not require periodic recharging. So you have a technology that is more efficient, dramatically cheaper to manufacture, eliminates a major source of greenhouse emissions, and lasts 3 to 4 times longer than what is currently sold in American homes. You cannot buy one, not legally, not anywhere in the United States. Here is why. The Department of Energy maintains a residential heat pump certification program that determines which heating and cooling products can be sold for residential use in the United States. Certification under this program is a prerequisite for almost everything that matters in the HVAC market. You need it to qualify for federal tax credits under the Inflation Reduction Act. You need it to qualify for utility rebates in every state that offers them. You need it for IECC code compliance on any new construction project. You need it for Energy Star labeling. Without DOE certification, a heat pump can technically exist as a piece of hardware, but it cannot participate in any of the financial or regulatory structures that make residential HVAC purchases. Viable DOE certification requires testing under a protocol called AHRI 210-240. This is a document maintained by the Air Conditioning, Heating, and Refrigeration Institute, a trade organization, and the test methodology is the gateway through which every residential heat pump in America must pass. Read the protocol carefully and a strange detail emerges. The test procedure does not just measure heating and cooling output, it measures specific behaviors of a vapor compression refrigerant cycle. It measures refrigerant subcooling temperatures. It measures compressor discharge pressure. It measures refrigerant superheat at the evaporator. It tests for line set pressure drop. The entire test methodology assumes, as a matter of physical setup, that the unit being tested is a vapor compression system using a refrigerant gas. A magnetocaloric heat pump has none of these things to measure. There is no refrigerant to subcool. There is no compressor to monitor. There is no superheat to test. The protocol cannot be applied to the technology. There is no failure mode where a magnetocaloric system fails the test. There is simply no test to run. In regulatory terms, this is not a ban. It is something more elegant than a ban. It is a definition of what counts as a heat pump that quietly excludes anything not built around the technology the existing manufacturers already sell. If this kind of breakdown is useful, hit subscribe. I cover the regulatory and incentive structures behind everyday American technology every week, and the next one is going to make you angry in a similar way. The AHRI itself is a trade organization, not a government agency. Its membership is made up of HVAC manufacturers. Its board of directors is dominated by executives from Carrier, Trane, and Lennox, the 3 companies that collectively control roughly 80% of the American residential heat pump market. The AHRI 210-240 protocol is, in effect, written by the manufacturers it certifies. The Department of Energy then adopts that protocol as federal standard. This is not a hidden conspiracy. The AHRI publishes its committee structure openly. Industry trade publications cover the certification meetings. The membership rolls are public. What is not openly discussed is what happens when a technology that does not fit the existing protocol shows up at the door. The certification pathway for a non-vapor compression heat pump exists in theory. In practice, the pathway is staffed entirely by people whose employers stand to lose enormous amounts of money if the technology gets approved. The relevant AHRI committee meets quarterly. Solid-state heat pump testing is not on its agenda. So how much money are we talking about? The American residential HVAC market is worth roughly $34 billion a year in compressor-driven unit sales. Carrier, Trane, and Lennox together capture about 80% of that. They sell the units themselves, they sell the parts, they sell the service contracts, and they have well-developed dealer networks built specifically around the assumption that a residential heat pump will need replacement or major service every 12 to 15 years. A magnetocaloric system that lasts 40 years collapses the replacement cycle. one purchase per home per generation. The dealer network, which makes most of its profit on service calls and replacement installs rather than initial sales, would shrink dramatically. The parts business, which depends on a steady stream of failing compressors and aging components, would shrink with it. Then there is the refrigerant business. American HVAC manufacturers and chemical companies sell roughly $8 billion a year in R-410A, R-32, and the newer hydrofluoroolefin blends being phased in to replace them under EPA refrigerant rules. Every residential heat pump installed today contains between 5 and 10 pounds of refrigerant that must be charged at installation, topped up periodically, and recharged or replaced when the unit fails. The refrigerant business is structurally dependent on the existence of vapor compression heat pumps. A magnetocaloric system uses no refrigerant gas at any point in its life cycle. The $8 billion refrigerant revenue stream does not shrink under widespread adoption. It evaporates entirely. Combined, the compressor unit business and the refrigerant business represent roughly $42 billion in annual American revenue, controlled by a small set of companies who also happen to dominate the trade organization that writes the federal certification protocol. This is what regulatory capture looks like at its most sophisticated. There is no need to ban a competing technology when the test methodology can simply be defined to exclude it. There is no need to lobby against new entrants when the gatekeeping committee is already composed of incumbent employees. There is no need for explicit collusion when the financial incentives align so cleanly that nobody on the relevant committee has to be told what the right answer is. Consider the parallel international situation. The European Union maintains its own heat pump certification framework through Eurovent, which has been doing preliminary work on test protocols for non-vapor compression systems. China has accepted HIRE's Magnetocaloric wine cooler under existing appliance certifications and is reportedly drafting residential heat pump protocols that explicitly accommodate solid-state designs. Japan's industrial research agencies have funded grants tied to magnetocaloric commercialization. The American DOE, by contrast, defers entirely to AHRI on the question of test methodology. AHRI has not moved. The technology in commercial terms does not exist in the United States, so what can actually be done about this? In theory, the Department of Energy has the statutory authority to develop independent test protocols outside the AHRI framework. The Energy Policy and Conservation Act gives the DOE direct rulemaking authority over residential appliance efficiency standards. In practice, the DOE has not exercised that authority against AHRI in the residential heat pump category in a very long time. The agency relies on AHRI technical staff for almost all of its standards development work, partly because the DOE itself does not employ enough HVAC engineers to develop independent protocols at speed a state could move on its own. State-level energy regulators have authority under existing law to certify residential equipment under state-specific protocols and require utilities to honor those certifications for state rebate programs. None have used that authority for solid-state heat pump certification. The reason given by state agencies when asked is essentially that they are waiting for the federal framework to update before acting. In the meantime, if you are a homeowner who would actually like to install one of these systems, your options are limited. You can purchase a residential prototype directly from Camfridge or one of its European partners under industrial or research use exemptions, but you cannot install it as a primary residential heating system without losing your insurance coverage and potentially failing your local code inspection. You can install HIRE's wine cooler legally as a small appliance since it is not subject to residential heat pump certification at that scale. You can wait, possibly for many years, while the regulatory machinery either grinds slowly forward or remains permanently stuck. The real question this raises is not whether magnetocaloric heat pumps will eventually be certified for American residential use. They almost certainly will eventually, once the political cost of blocking them exceeds the lobbying budget required to maintain the status quo. The real question is how many billions of dollars in heating bills, how many tons of refrigerant emissions, and how many years of climate progress will be lost in the gap between when the technology became viable and when American regulation finally caught up. The technology is ready. The economics work. The hardware exists in working consumer products today. The only thing standing between an American homeowner and a 40-year, refrigerant-free, dramatically more efficient heating system is a test protocol written by the companies that would lose the most money if it changed. If you want to see how this same regulatory capture pattern plays out in American residential insulation, where a NASA-derived material called silica aerogel has been kept out of homes despite passing every federal fire test, that video is on screen now. Subscribe for more breakdowns of the systems most people never look at.